So the next thing we're going to look at is raising a plane. So key thing to remember is it starts off at 0 degrees here and it goes around in an anti-clockwise direction. So here is going to be 90 degrees. And it's 180, 270. That just goes back to 360. So yeah, so remember, we'll just mark it in a different color. That this is the positive direction. And you can also go back the other way. So if we go back the other way, this is negative. So we could say that this is negative 90 degrees here. That'll be negative 180. This would be negative 270. Then it's also negative 360 here. So important thing to remember is that the angles are pretty much the same if you go around in a 360 degree rotation. So if you test sine 30, you notice the same as sine 390 or sine 750. So yeah, so if you notice here, 40 add 360 is 400, you minus 360 is minus 320. So it's just going about multiples of 360. So you can test that out on your calculator if you want to. Alright, so next we'll look at general angles, or angles of any magnitude. So a more formal definition of sine, cos and tan is if we take it to be so we know that this theta there. So then across that's the x value. The rise is y, and then we know that distance there is the radius of the circle, so it's going to be r. So in our definition of sine, opposite over hypotenuse is y over x. Y over r, sorry. And then cos, adjacent over hypotenuse, x over r. And then tan, opposite over adjacent, so it's y over x. So that's just looking at it in this first quadrant. So next we're going to look at the signs of these trig functions. So yeah, so if you get your calculator, you can test. So you know that in between here is between 0 and 90 degrees. So if you test like sine, just say 40, it's between 0 and 90, you get a positive sign. So if you test a number between, say, sine, just say 91, because it's between 90 and 180, just test it and see what you get. So remember, so this first quadrant here, it's 0 to 90 degrees. Second quadrant is 90 to 180. Third's 180 to 270, and then the last is 270 to 360. So yeah, so we just write that down. So this is the first quadrant. So that's second. Third and fourth. So yeah, so just get your calculator and test angles between each quadrant and see what signs you get, and then I'll fill out the table for you. Alright, so if you tested it out correctly, you would have found that sine is positive in the first two quadrants, cos was positive in the first and the fourth, and tan was positive in the first and the third. So these are important results, but there's a memory trick we can use to help us memorize this. So yeah, if we look at the quadrants, So if you remember, in the first quadrant, everything was positive. So we're just going to write all positive. In the second quadrant, you notice that only sine was positive. In the third, you'll notice that only tan was positive. And the fourth, you'll notice that only cos was positive. So there's a memory trick that we used to use. So ASTC, we just say all stations to central. So now that A stands for all, S is sine positive, T is tan, and C is cos is positive. So we'll just write that at the bottom here. Another key thing I want to highlight is that in this first quadrant, the angle is going to be theta. Second is 180 minus theta. Third's 180 plus theta. And the fourth is 360 minus theta. So it'll make a bit more sense as we move on. You can see that as the rays are drawn, that's how we're going to get the angles. So the next bit, we're going to look at the angle and the related angle. Alright, so the related angle is pretty much the angle between the x-axis and your ray, or the line. So that there, that's your related angle. So yeah, so as we're shown here, it's always between the x-axis and the line. So it's not in this, doesn't come from the y-axis. So since these are all the same, that's 30 there. So here, remember we wrote before it's 180 minus theta, so 180 minus 30 gives us 150. 180 plus theta gives us 210, and 360 minus the theta will give us 330 in this case. So remember it goes around, so 0 degrees, 90, 180, 270, so it goes around clockwise. So it's important to note that, like just say if you pick the sine, cos, or tan of the same angle, they're pretty much all the same magnitude, it's just different sign based on which quadrant it's in. So yeah, the trigonometric functions of any angle theta are the same as the trigonometric functions of its related angle. So yeah, so apart from the sign changes, it's the same magnitude as I said earlier. So we're going to use this idea to help us find exact values. So the first step I want you to do is draw a quadrant diagram and place the ray in the correct quadrant. Then you pretty much use ASTC to work out the sign of your answer, find the related angle, then just work out the value of the trig function at that related angle. So yeah, so we follow those steps. First thing to do is draw a quadrant. So 300 degrees, the ray would be roughly here. And we know that that's 300 there. The related angle here is going to be 60. Because we know that 360 minus theta, so minus 60 will give us 300, the angle we want. So now, we work out the value of tan 60. So notice how that wants the exact value. So remember we did exact values for 30 degrees, 45, and 60 degrees. So remember your tan 60 is going to be root 3. So then tan 300 you know it's going to have the same value as tan 60, so it's going to be root 3, but tan is negative in this quadrant, so it's going to be negative root 3. Alright, so next one, sine negative 210. So remember 0 degrees starts there, so we're going to go around in a clockwise direction now. So it'll be 90, 180, and 270 there, so it'll be roughly here. So now that's theirs. So if that's 180, it's going to be 30 degrees in between them. So exact value of sine 30, you might remember is a half. And all stations to central, so S, so sine's positive in there. So sine negative 210, it's just going to be positive a half, so it stays the same in this case. So alternatively, another way you can do it is so remember we can go around in 360 degrees and it will still be the same angle. So if we did negative 210 plus 360, you get 150. So if working out sine 150, you get the same answer. So that's just if you don't like going backwards in the negative direction. You just add 360 and you notice that sine 150 is exactly the same. So next one. So we need a similar idea. So cos 570, because we don't want to go around twice, so we're just going to minus 360 from it. And you'd get 210. So finding cos 570 is the same as finding cos 210. So remember it'll be 0, 90, 180, and there'll be 270 there, so it'll be there, so it'll be 210. And then 210 minus 180 gives us that 30 degrees in between there. So now we're going to find cos 30. So using your exact values, you get that as root 3 over 2. But remember, all stations to central. So tan is positive here, so cos is negative. So the answer is going to be, for cos 210, it's going to be negative root 3 over 2. Alright, so we've looked at finding angles between the endpoints. So now we're going to look at finding angles that are on the boundaries. So 0, 90, 180, 270, and 360. So if you actually type it in your calculator again, if you do like sine 0 or sine 360, you get 0. If you did 90, you get 1. 180, you get 0. And 270, you get negative 1. So if you want, you can just pause it and try on yourself, but I'll just write down the answers quickly. So you notice for the tan graph, you would have got errors, because these are actually asymptotes. So yes, if you notice at the bottom of your page, you notice the trig graphs. So yeah, your sine, your cos, and your basic tan graph. So generally you're expected to know between 0 and 360 degrees. So one period or one cycle of the sine graph, one period of the cos graph, and one period of the tan graph. So notice how the tan graph has asymptotes at 90 and 270. As we said before, if you type it in your calculator, it doesn't work. So yeah, so just take a quick note between 0 and 360 for all the graphs because you're expected to know this basic shape. Alright, so in this next section, we're going to look at finding exact values of trigs if you're given one function. So a key thing to remember is if they give you an exact value, so just say in this case at the bottom here, cos 4/5, just go back to your basic right angle trig. So remember, it can be formed as a right angle. But yes, in general, you want to draw the rays in the correct quadrant, use SOHCAHTOA and Pythagoras if required to find the unknown side, and answer the question taking note of the sign. Alright, so the first thing we'll do is cos 4/5. So if you want, you can actually do an extra step at the start. So I'll just show you that extra step. So we're just going to draw a triangle. Theta, so cos is adjacent over hypotenuse. And that's x there. So now this is a basic, you know this is going to be a basic 3, 4, 5 triangle. So you know it's going to be 3, but if you didn't know, just use Pythagoras. So yeah, if you want, you can actually draw this triangle on the side. You don't have to, but it's just an extra step if you want to. So now notice how cos 4/5 is positive, so it's either going to be there or there. But you have to use all the information they give you. So notice how it says that sine theta is less than 0. So that means that sine is negative. So that means that the one we're looking for has to be that ray. Because cos is positive and sine is negative there. So we know that if that's theta there, that's 5, 4, and the height is going to be 3. So now tan theta is going to be opposite over adjacent, so 3/4. But then, notice how it's in this quadrant. So only cos is positive here, so tan would be negative. So the answer is negative 3/4. So yeah, let's do the next one. So find all possible values of cos theta if sine theta is 1/5. Alright. So let's just draw the quadrant again. Or the plane, sorry. Alright, so sine theta is 1/5, so it's positive, so there's two possibilities. So it's either going to be one of those two. So I'll just change color. Alright, so theta, and there's going to be theta there as well. So the height is 1, the radius is 5. Sorry, hypotenuse is 5. So you have to find the adjacent side. So using Pythagoras, it's going to be the square root of 1 squared plus 5 squared. Sorry, 5 squared minus 1 squared because you're finding a shorter side. So that'll be square root 24, which simplifies down to 2 root 6. So that means that you can put it on your diagram now. So it says find all possible values of cos theta. Since we know it's in these two quadrants, so you know cos theta equals, so adjacent over hypotenuse, so 2 root 6 over 5. So that's the first quadrant. And the second quadrant, you know, it's also going to be 2 root 5. But think about, is cos positive or negative in that second quadrant? So you know it's negative because only sign's positive there. Alright. So for the second bit, find cos theta if also tan theta is less than 0. So that gives us an extra condition now. So we know that it can't be that first quadrant because tan's positive there. So it has to be the second quadrant. So yeah, so cos theta equals negative 2 root 6 over 5. And if you wanted to put a reason in brackets saying that tan is negative in the second quadrant. Alright, I'll let you guys try this last one on your own. But just remember, take in mind that's negative. So remember, draw the two rays where sign is negative. So yeah, I'll give you guys time to do this.